In this video, I will be showing how to make a compact desalination kit to turn salt water into drinkable fresh water. This design functions as a normal water bottle when it's not in use, so it hardly adds any weight to what you would normally carry on a hike. Desalination is a simple process. When salt water is boiled, the water evaporates into steam, leaving the salt behind. If we can collect the steam and condense it back into liquid water, it will be absolutely pure. This is actually a small problem, because drinking water with no minerals in it at all can be harmful to your health by depleting your electrolytes. But that issue is easily solved, as I'll demonstrate later. The first item required for this project is a stainless steel bottle. Some bottles like this have a double wall to insulate the contents, but for this project we just want a simple, non-insulating bottle with a steel lid. The condenser portion of the desalinator will be made from 1/4 inch copper tubing, so to attach it to the bottle, I first had to learn how to solder copper to stainless steel. I practiced this on a stainless steel bowl, and it's a good thing I did because my first attempts were not great. I learned that it's important to clean both the copper and stainless steel with a bit of sandpaper before soldering, and the process requires a generous amount of flux applied to the joint beforehand. Since this will be in contact with drinking water, it's important to use lead-free plumbing solder, not the stuff made for electronics. My best results used only very gentle heat from my torch, just barely getting the metal hot enough to melt the solder until it joined the two pieces. A spritz of rubbing alcohol from a spray bottle cleans up the excess flux, and you can see how much I improved from my first attempt to my last. Now that I'm prepared to work on the real bottle, the first step is to remove the lid and any gasket that makes a seal. This is set aside for now so it doesn't get damaged. The lid now needs a hole drilled all the way through it to accommodate a piece of copper tubing. One of the first tools I ever wanted when I was a kid was a drill press to make this sort of task easy, but you could also get this done with a hand drill. I also made a tiny hole near the edge of the lid so that air will be able to escape from inside as I heat it with the torch. I'll plug this later. After preparing the surface around these holes with sandpaper, a bit of copper tubing is pushed through them, enough to stick out about 1/2 inch from both sides. Then I just soldered the tube in place, following the process I learned earlier, both on the top and bottom of the lid. The tiny hole I made to release air pressure was small enough that I could just use a soldering iron instead of a torch, but the process of sanding, then adding plenty of flux around a tiny piece of solder worked the same way. With this part completed, the silicone gasket can be reinstalled in the lid, and the whole thing screwed back onto the bottle. The short section of copper sticking out of the top will connect to a longer piece of tubing using a right angle compression fitting, which can be pressed into the lid and tightened down to lock it. On the other end, the little piece sticking out can be removed. It's not really needed for copper tubing anyway. Instead, I take a little piece of rubber and press it into the lock nut before screwing it back onto the fitting. This will make an airtight seal when the design is being used as a water bottle, and to use the desalination feature, you simply pop the rubber piece out first. Now the 1/4 inch copper tubing I have used so far in this project is sold in large coils for use as water lines leading to a refrigerator or freezer. To form my coil for the desalinator, I simply take this tubing and start wrapping it tightly around the bottle. I found that 8 or 9 turns looked pretty good, and that should be plenty of tubing to recondense the steam when we boil water inside the bottle. I decided to bend the ends of the coil outward, so that when one end is pressed into the fitting on the bottle, the other side will be sticking straight out. As fresh water drips from this end, we want it to be easy to collect. And that's it. Now we just need to give this project a try. After removing the rubber seal from the fitting, the coil slips right off the bottle and presses back into the fitting with only a small amount of force. This bottle has a ring built into the lid, which makes it really easy to hang from a hook or piece of string, which is good since we need to suspend this bottle over a fire. I have in this beaker some salt water, equivalent in salinity to ocean water. You can tell just how much salt is in this by the residue it leaves behind when it boils. This is what we will aim to remove with the desalinator. The salt water is added to my bottle and then reattached to the lid, which is now hanging over a heat source, in this case my small soup can stove. This little stove I made in an earlier video, and it's great for cooking over, but in this case it was a cold, windy day, and it was too much to ask of such a small stove to keep water boiling in a bottle when the wind kept blowing the flames out from under it. When there were breaks in the wind, I did start to see some water production, but to speed things along I switched in a larger coffee can stove. This worked much better. You could of course just use an open campfire to heat this bottle. A stove just makes things easier. This time the stove was actually so hot that the steam production outpaced the rate that the coil could cool it back down into water. We can see drips forming, but also quite a bit of steam exiting the tubing. This is wasteful, so we need to cool the tubing down until we're only seeing liquid water coming from the end. An improvised way to do this is with a piece of fabric. If you were hiking, this could be the shirt off your back. We wet this with cold salt water and wrap it around the coil. This will need to be wet again with cold water regularly as the coil heats it up, but doing so will greatly improve freshwater production. An even more efficient method, if you have an extra container, is to dip the whole bottom half of the coil into water. This works so well that all of the steam will stop flowing, and it will seem like water production has stopped. But in a few moments, water will have filled the coil and resume pouring out of the end. With this setup, you will end up with almost all of the water you started with, free of salt. One final efficiency tip is that once you have built up enough water in your collection container, the end of the tubing can be dipped into it, and in that way your fresh water itself will act as a condenser for any steam that exits the tubing. It's good to stop boiling the salt water in the desalinator before it runs completely dry, or you'll end up with a hardened mineral cake lining the inside. I started with about 250 milliliters of salt water. I ended with about 175 of distilled water. Now, as I mentioned at the start of this video, it's unhealthy to drink pure distilled water. So the desalinator is cracked back open, and before drinking the fresh water, just a small splash of the concentrated salt solution is added back in. Just a few drops is fine. The rest should be poured out. Now this water is perfectly safe to drink, and if ocean water is all you have, it could very well save your life. This is what the water now looks like being poured out on a burner, this time with much less salt. You might wonder if this desalinator would work with solar power, like a Fresnel lens or parabolic mirror. Definitely it could be used with either of those heat sources, which I may experiment with later. For best results with solar, the bottle should be painted black for maximum light absorption, and as you can see, this happens automatically the first